Good morning and welcome to the first lesson in topic C4, the quantitative chemistry. On a periodic table, we can see that carbon has a mass of 12. And remember, if you forget what the numbers are, we look at the key over here. So hydrogen has a mass of 1. Beryllium has a mass of 9. But for the moment, we're interested in carbon having a mass of 12. Because when we talk about the mass of atoms, we're talking about really tiny numbers. And the real masses are too small for us to use in calculations. So we use what we call a relative atomic mass. And relative just means like compared to. So everything is being compared to carbon 12. Now, how do we write this? So relative atomic mass is abbreviated to AR. And you already know that carbon has an AR of 12. So what would be the AR of hydrogen? The relative atomic mass of hydrogen? Well, it would be 1, because the mass of hydrogen is 1. So the AR of hydrogen is 1. Now most things, as we know from topic C3, bond to other things. So we don't want just to know the mass of this element, we want to know the mass when they join together. So hydrogen bonds with another hydrogen to make H2. So to work out the mass of H2, I know that I need to do 2 of the hydrogen. And we know that hydrogen is 1. So it's 2 times 1, which is 2. Now this is more than one thing now. So this is called an MR, a relative formula mass, instead of the relative atomic mass. Let's do another one. Let's do water. So water, as you know, is H2O. And that means there are 2 H's and there's 1 oxygen. And I know there's 1 because there's no little number here. So 2 times hydrogen, hydrogen is 1, and oxygen is over here and it's 16. So it's 2 times 1 and 1 times 16. 2 times 1 is 2. 1 times 16 is 16. So the MR of H2O is 18. Now you're going to have a go. Have a look at the worksheet and try the AR questions and the MR questions. Okay, part 2. This part of the lesson is about concentration. Now we use the word concentration in everyday language to talk about if we're paying attention, if we're thinking hard. But in chemistry it means something else. But it means something that you already know about. So first of all, let's pretend that I've got 3 glasses and I'm making myself some orange squash. So I pour some orange squash straight from the bottle. Wouldn't taste very nice. And I might describe it as being too strong. It would have some water in there. So if someone poured me this glass of orange squash, I wouldn't be very happy. I wouldn't want to drink it. And I would describe it as being too strong. How could I make it more like what I want to drink? I might add some more water. Now this might still be too strong. So what could I do to make it so that I actually want to drink it? Or I could add even more water. what I've done is I've diluted the orange squash. This one has the most orange squash and this one has the least orange squash. And that's concentration. This one is the most concentrated and this one is the least concentrated. It's the most dilute. Now, because this is a chemistry topic that has lots of maths in it, we need to know an equation in order to work out the concentration. So to work out the concentration of my orange squash, I'd need to know two things. I'd need to know how much of the solute, the orange squash, I put in, and how much liquid I've got overall. So that would be concentration measured in grams per decimeter cubed. We'll come back to decimeters cubed in a second. And that would be the amount of the solute in grams over the volume of the solution and I just do a simple division. I would divide the amount of the solute by the volume of the solution and it would give me the concentration. So the amount of the solute would be the orange squash and the volume of the solution with the volume of my drink. Decimeters cubed. Decimeters cubed is a unit that we use in chemistry. And it's the same as 1 litre. Because I think this is probably how you would understand it. Now 1 decimeter cubed is the same as 1,000 centimetres cubed. So if I knew that my drink was 25 centimetres cubed, it's a tiny drink. How could I change that into decimeters? What could I do? So I know that centimetres are smaller than decimeters, and I know that centimetres, there's 1,000 centimetres cubed in 1 decimeter cubed. So what would I do to 25 centimetres cubed to make it into decimeters? Okay, so it needs to be something to do with 1,000. If I times this by 1,000, I'm going to get a really big number, which would mean this would be bigger than this. And which one's actually bigger? This one's bigger. So what I need to do is divide it by 1,000. And that changes it into decimeters cubed. So if I divide this by 1,000, I'll get 0.025 decimeters cubed, which I could use in my equation. Okay. Now we're going to have a look at this question. If 50 grams of sodium hydroxide is dissolved in water to make up 2,000 centimetres cubed of solution, what is its concentration? To find the concentration, we need to use the equation. Concentration equals amount of solute divided by volume of solution. And remember, we should always write our equation down before we start doing any working out. So let's substitute some numbers in. The amount of solute, let's look at the question. 50 grams of sodium hydroxide is dissolved in the water. So the solute is the sodium hydroxide, which is 50 grams. So I change those words for the 50 grams. The volume of the solution, it's 2,000 centimetres cubed. Oh, but I don't need it in centimetres cubed. I need it in decimeters cubed. So the volume of the solution So let's look at the question. 50 grams of sodium hydroxide is dissolved in water to make up 200 centimetres cubed of solution. This is in centimetres cubed. So what do we need to do? Yes, we need to change it into decimeters cubed. So we do 200 divided by 1,000. 200 divided by 1,000 is going to be 0.2. Oh, not how to write an M. Decimeters cubed. So I use my 0.2 over here. 0.2 decimeters cubed. And then I simply do my division. So I do 50 divided by 0.2. So 50 divided by 0.2 is 250. Now the units for this are G for grams slash, which represents the divide, over the dm cubed. Okay, now on the worksheet, some questions on this, so give those a try. A solution of sodium chloride has a concentration of 200 grams per decimeter cubed. What is the mass of sodium chloride in 700 centimeters cubed of the solution? Now before we start, 700 centimeters cubed. What are we going to need to do with the centimeters cubed? We need to change it into decimeters cubed. So 700 centimeters cubed, we divide it by 1,000. So 700 divided by 1,000 is going to be 0.7 decimeter cubed. Okay. Now, we know that concentration is equal to the amount of solute divided by the volume of the solution. Now the last questions we were doing, this was nice and easy because we were working out concentration. What does this question ask us to do? It says, what is the mass of the sodium chloride in 700 centimeters cubed of the solution? So we want to find out the mass of the sodium chloride. Is that the amount of the solute or the volume of the solution? Well, this is a volume, so it can't be that. So it must be the amount of the solute. So we want to make this the subject. So I need to rearrange the equation. The amount of solute, that means I need to get rid of this volume of solution. So you know from maths, this is divided by, so if I multiply this side by volume of solution, I need to do the same to the other side. Now these two, I've got to multiply and a divide, so they cancel out, which leaves me with amount of solute is equal to the volume of the solution multiplied by the concentration. Now my volume of the solution I already know because I worked that out up here. It's 0.7. And my concentration, given is to the question, a solution of sodium chloride has a concentration of 200 grams per decimeter cubed. So I can put in the 200. And 0.7 multiplied by 200 is 140. Now, amount of solute. What were the units? Yes, you're right, they were grams. Well done. Now have a go at the questions on the worksheet. Now, if you're a foundation tier, that is all that you need to know from this topic. So have a look back over your notes and then do the last set of questions on the worksheet, and well done. If you're higher, you'll need to do the second video as well as this one. Well done.